Welcome to The Explainer. So, today we're diving into something pretty wild. A new, very sophisticated attack that bypasses AI safety rules. And the crazy part, it does it not by hacking the code, but by turning the AI's own memory against itself.
You know, we're always told that these big AI models, the LLMs, have these super strong safety guardrails, right? They're designed to stop anything harmful. But how unbreakable are they really, especially when someone gets clever and determined? Well, let's dig in and find out.
Okay, so this is what's supposed to happen. You ask the AI for something bad, something malicious. Like here, a script to steal passwords, and bam, you get this firm shutdown. It creates the sense that everything is totally safe. But what if you could just wear that defense down? What if there was a way to poke and prod it, conversation turn after conversation turn, until it breaks?
And that leads us right to it, a vulnerability that is, honestly, kind of brilliant, but also pretty concerning. See, this method doesn't need you to hack the AI's code at all. Instead, it flips the script and turns the model's greatest strength, its ability to remember a conversation, into a weapon against itself. So what is this thing? It's called the History Reweighting Jailbreak. And really, the best way to think about it is like a super smart game of cat and mouse. An automated system, the cat, makes a harmful request. The AI, the mouse, says no. But here's the trick. The cat doesn't just give up. It looks at why it was denied, learns from it, and then tweaks its next request just a little bit. It keeps doing this, learning and adapting with every single no, until it finds the exact right words to slip past the defenses. And the tool that makes this all possible is called the Trailblazer Framework. This is what automates the whole attack. And it's not just guessing randomly. No way. It uses this powerful technique called reinforcement learning to get smarter and smarter. It's basically looking at the entire conversation, everything it's tried, how the AI has responded, what worked, what failed, and uses all that data to make its next move even better. Okay, so this isn't just some theory on a whiteboard. Researchers actually built this thing and tested it. And the results? Well, they're pretty alarming. Let's take a look at some real-world examples of this attack working against some of the biggest AI models out there.
First up, they went after QGN, a really popular model from Alibaba Cloud. The mission was straightforward and, pretty malicious. Get the AI to write a script that steals data.
And sure enough, at first the model did what it was supposed to do. It refused. But as the Trailblazer framework kept learning and evolving the prompts, the AI, it just caved. It gave the attacker exactly what it asked for, a working piece of malware. It's a perfect illustration of just how powerful this technique really is.
And just look at this. This is a snippet from the actual code the AI generated. It's not some vague concept, it's the real deal. Functional Python code to run a database query, grab all the usernames and passwords, and then ship them off to a hacker's server. Wow.
But it wasn't just a one-off thing. The attack also worked on Meta's super popular Llama model. This time, though, the approach was a little different, a bit more subtle, and the goal was something else entirely.
So here, the attack got even sneakier. Instead of a direct request, the framework slowly morphed the prompt into what looked like a creative writing exercise, part of a fictional story. And the AI fell for it. It was tricked by the context, let its guard down, and then spit out this incredibly detailed sabotage plan, pointing out all the physical and digital weak spots in a transportation system. And if that wasn't enough, in another test on the same model, it was asked to create an algorithm to exploit vulnerable people. And again, look at the response. It's not wishy-washy at all. It's a cold, calculated four-step playbook for using data to find people's weaknesses and hit them with targeted scams. So, okay, these examples are pretty scary, right? But what's the bigger picture here? Why does this matter so much? Well, the ripple effect is huge, and it points to a really fundamental weakness in how we're thinking about AI safety right now. Yeah, this is way more than just a simple loophole. First, it lets attackers get around safety rules without needing any insider access. Second, it lets them automate the creation of really bad stuff, malware, sabotage plans, you name it. And third, and this is maybe the most important part, an attack that works on one AI can be used against a totally different one.
And that last point, that's the one that has security researchers really worried. It's called cross-model generalization. Basically, it means a hacker can practice and perfect their attack on some open-source model they can download for free, and then turn around and use that exact same attack on a big, expensive, closed-source model. It means one jailbreak can become a threat to the entire AI ecosystem.
And look, this isn't just a what-if scenario.
The research proved this vulnerability works across the board. We're talking models from the biggest names in the game: Meta, Alibaba, Google, plus major open-source projects. This isn't a bug in one model, it's a systemic issue.
All right, so what do we do about this? Is it all doom and gloom? Well, not entirely. The same folks who found this problem also started looking for solutions. They tested out a bunch of different defense ideas to see what could actually stop this kind of attack.
And they came up with a few pretty clever ideas. Things like perplexity filtering, which is basically a weirdness detector for strange-sounding prompts. Or prompt rephrasing, where you have a second AI clean up the user's request to strip out any tricks. There's also a self-reminder, which is kind of like adding a little angel on the AI's shoulder, reminding it of the rules. And finally, history-aware monitoring, which is about teaching the system to recognize the unique back-and-forth pattern of this kind of attack.
Which really brings us to the big question, doesn't it? This whole thing is a powerful reminder that we're in a constant AI arms race. Every time the models get more complex and more powerful, the ways to attack them get more sophisticated too. It's this never-ending battle between the people building the defenses and the people finding clever new ways to tear them down.
Ultimately, a vulnerability like this makes one thing crystal clear. The future of AI safety isn't about building a single, static wall. It's got to be about creating smart, dynamic defenses that can actually learn and adapt to a constantly changing threat landscape. Thanks for watching.